Imagine we want to encode DNA strings. So remember that DNA is over the alphabet A, C, G, T. We have 4 different characters that we want to encode, so if we wanted to encode them in binary, which would be easier to represent on a computer, if we have 4 options, we could theoretically represent those in 2 bits. So for example, I could represent A as 0, 0. I could represent C as 0, 1. I could represent G as 1, 0. And I could represent T as 1, 1. So if I had, for example, the string ACGT, this string would be represented as 0, 0 for A, 0, 1 for C, 1, 0 for G, and 1, 1 for T. In addition to representing these by just some concrete mapping, I could represent this encoding using a tree, a coding tree specifically. So let's imagine a tree structure. It's actually a trie where I have edge labels that are labeled in whatever I'm trying to encode, whatever the target, like the destination encoding is. So in this case, I want to encode into binary. So I will have each edge labeled with a binary character. And then the characters that I want to encode from, which are A, C, G, and T, will represent leaves in this tree. A, C, G, T. And I can represent every single character in my alphabet as the path from the root to the node labeled by that character. So A is represented by the path 0, 0. C is represented by the path 0, 1. G is represented by the path 1, 0. And T is represented by the path 1, 1. So given this tree structure, if you gave me some potential query sequence, for example, if you gave me 0, 0, 0, 1, 1, 0, 1, 1, and I wanted to decode it, I could use my coding tree. I could start at the root and then say, okay, the first character is 0. Okay, now I'm here. The next character is 0. Oh, I saw an A. Now let me go back to the root. Now I see a 0. Next character is a 1. So 0, 1. Oh, I saw a C. Go back to the root. Next character is a 1. Next character is a 0. So I saw a G. Go back to the root. Next character is a 1. Next character is a 1. So I saw a T, and I'm done. So given a coding tree, and given some encoded message, I can easily reconstruct my original message. The algorithm is trivial. I just start at the root, and then for each character that I see in my encoded message, just traverse the corresponding edge. Anytime I end up at a leaf, I would just output the corresponding character.